In this video, we'll cover the material in Chapter 10 and Section 10.7, the applications of radical expressions and equations. And we'll have some examples in here, so this will be both content and examples. The first is to learn how to use the Pythagorean Theorem. It's something that you'll have to memorize if you haven't already. Second thing of our objectives is to learn about two kinds of special triangles that also have special formulas that we use to calculate the sides. And then we'll learn about the distance formula and the midpoint formula. You'll need to memorize both of those, and we will learn how to apply them. So the Pythagorean Theorem tells us that in any right triangle, that the squares of the legs, so square each leg and add them together, and that's going to equal the square of the hypotenuse. The hypotenuse being this side that's right across from the right angle. Another thing that we'll need to know here is that the principle of square roots tells us that if x squared equals n, then x is either going to equal the positive or negative root. So remember, we talk about principal square roots, but when it's an equation, then we have both the positive and the negative as solutions to the equation. Okay, Pythagorean Theorem problem. Okay, and it's set up, here's our pole, our 14-foot pole's right here. And here's our guy wire. And you'll see that it's 8 feet out from the wall. So basically we're going to use Pythagorean Theorem, which tells us we have 8 squared plus 14 squared equals d squared. 8 squared is 64. 14 squared is 196. So d squared is going to equal 260. Not a perfect square, but when we take the square root of both sides, that's what we're going to do, is we're going to take the square root of both sides, and we'll get d equals the square root of 260. The biggest perfect square that you can find in there is 4, so that comes out as a 2 times the square root of 65. And that is the exact answer. Now, we just talked about the principle of square roots, and then I only gave the positive answer. Why is that? Because length can only be positive. So you have to see what makes sense with the problem. This is the exact answer, and if a problem doesn't designate, leave it as the exact answer. But sometimes you'll also be asked for the approximate answer, and that means you'll go ahead and take the square root of 65 and round the decimal that you get, and that's called an approximate answer because it's not spot on because you've rounded a decimal. Okay, we're going to learn about two kinds of special triangles, and the first kind is called, I call it a 45-45-90 triangle, but it's an isosceles right triangle. And the hypotenuse is a times the square root of 2. So if we look at the next, a better, I think, representation of this. It's A and A are the sides of the triangle, and A times the square root of 2 is the hypotenuse. Now you can get this from the Pythagorean Theorem, and if you want to work that out, that'd be a great little exercise to work it out, to convince yourself of it, or you can just memorize it, okay? The hypotenuse is A times the square root of 2. So in this example, we have the hypotenuse, whoops, that wasn't brilliant. We have the hypotenuse is A times the square root of 2. So A equals 8 over the square root of 2. We always want to rationalize our denominators. And 8 over square root of 2, if we multiplied it, I'll just show you real quick, by the square root of 2 over the square root of 2, this would become 2. We'd have 8 divided by 2 is 4 square roots of 2. So that's what A equals. Now we're just talking about exact answers. That's the exact answer. The approximation of that is A equals, so you take your calculator, and it'll be 4 times the square root of 2 equals 5.657 to 3 decimal places. So that's the approximation. Okay? Make sure you give the answer that you are being asked for. Now 30, 60, 90 right triangles are another special one. And this will become also really special when you take trig. So it's kind of a fun triangle to work with. One side is A, the hypotenuse is 2A. And the other leg is A times the square root of 3. So the shorter leg times the square root of 3. So again, this is one that you're really going to have to memorize. And we'll do this example. I think I need to move this up a little bit too. Okay, we'll do this example where the shorter leg of a 30, 60, 90 right triangle. So the shorter leg, which is the one down here at the bottom, measures 12 inches. Okay, so this one's 24 because this is twice the shorter leg. And this one is 12 square roots of 3. So that's according to our formulas. Okay? So 12 and 24 are both, they're exact answers that you don't need to worry about approximating. But this 12 square roots of 3 over here, 12 times the square root of 3 is 20.785. Let me write that in another color. It's 20.785. And it's okay. In this, there was no real equation to write out. It was just asking to find the lengths of the other side. So it's okay to just label this, be very clear with it. Distance formula. The distance between any 2 points can be found by subtracting the x-coordinates and squaring it, adding the distance between the y-coordinates and squaring it, and then taking the square root of that whole thing. Okay, again, this is a formula that you are going to need to just memorize. Okay? So the distance between these two, well, we have the distance equals the square root of. What is 5 minus 3? It's 2 squared is 4. So that's x minus x, x2 minus x1 squared, 4. y2 minus y1. Negative 6 minus 1 is negative 7. Square that and it's 49. So we have a distance of a square root of 53. I don't see any perfect squares in there. So that's the exact answer. Exact answer is this. The approximate answer would be, putting it on your calculator, the square root of 53. And you would get D equals 7.280. So there is your approximation. Again, be careful that you know what you're being asked for and give the approximation or the exact answer. Okay, midpoint formula. Move this up a little bit too. I don't like how these things are falling down. Okay, so we have a midpoint formula where we have the endpoints of the segment, and then the coordinates of the midpoint, you just add the coordinates together, the x-coordinates together, and divide by 2. You average the coordinates. Okay? Notice there are no square roots in that. Nice, nice. So to find the midpoint of this segment, you would add 3 and 8 together. 3 plus 5 together, you'll get 8. And divide by 2. You'll add 1 plus negative 6, which is negative 5, and divide by 2. So 8 divided by 2 is 4. And you can just leave this in this form, negative 5 halves. And that is the midpoint of the segment. Now, if you want to check that that's the midpoint should be equidistant between both endpoints. So if you applied the distance formula from one endpoint to the midpoint, and then applied the distance formula from the other endpoint to the midpoint, you should have the same distance between them. And that's a good way to check and get a little bit of practice with both formulas.